Welcome to our grade 11 chemistry demo, Chemistry for Dummies. I am Saila.
And I am Sam. Sam I am. I do not like green eggs and ham.
Today we will be demonstrating the wonders of the gas laws. This includes discovering and learning about Gay-Lussac's laws. We will be demonstrating the way that temperature and pressure affect gases when the volume is held constant.
We will be using an egg and an Erlenmeyer vacuum, and then after the demonstration we'll be explaining what exactly was going on that caused the reaction.
Firstly, we'd like to inform you of the importance of proper safety precautions in this lab. Since we'll be using an open flame today, we will need to tie our hair back, wear closed-toed shoes, and wear goggles. Be careful not to roughhouse in the laboratory to avoid broken glass or slips and falls, which can pose as a threat to personal injury.
For this procedure, we will need a 1 liter Erlenmeyer flask, clean and dry, 2 to 3 birthday candles, a lighter to ignite the birthday candles, and the strip of paper to go in the flask during the first experiment. You will need food coloring, which is optional in this case of this procedure. You will need at least 1 hard-boiled egg, peeled. And also some tongs, and your written procedure is mandatory. In preparation for this lab, you must ensure that your egg is fully hard-boiled. This will prevent any ripping or tearing or spills. After peeling the hard-boiled egg, you may optionally dye it to make the experiment more interesting, just as we have done in the next clip. We decided to make ours green, just like so.
Let's take this over that way.
I'm just going to have no proof of it for now.
Probably not.
I might have
Yeah, no.
The first experiment we will be demonstrating is the basic egg and Erlenmeyer vacuum. For this experiment, we will start by ensuring that the flask is clean and dry. Next, we will be lighting the strip of paper on fire and then dropping it into the flask quickly. Then, cover the mouth of the flask with the boiled egg quickly and watch as the egg is sucked into the flask.
I got some water first.
3. Got it?
For our second experiment, we will start by placing 2 to 3 candles in the narrow end of the boiled egg. Then, after lighting the candles, we will be taking the second flask and holding it upside down with the lit candles in the mouth of the flask. Ensure that you hold the candles in the mouth of the flask for at least 6 seconds to ensure that the air inside of the flask is heated.
Here is another representation of this experiment with the candles in the narrow end of the egg and holding the candles in the mouth of the flask to heat the air. Then watch as the egg is sucked into the flask, and as I let go, the egg continues to move upwards into the flask.
Both of these experiments involve the same gas laws, and they have the same concept. Both of the experiments explain Gay-Lussac's law, which is used when the volume is held constant. Gay-Lussac's law states that when the volume is constant, the pressure and the temperature are directly proportional. This means that as the temperature increases, the pressure will increase as well, and vice versa. The temperature is the independent variable in this situation, whereas the pressure is the dependent variable. The purpose of placing a burning piece of paper in the large flask is to increase the temperature of the air inside of the flask. As the temperature increases, so does the pressure inside of the flask. It increases because it's directly proportional, and the kinetic energy increases as the temperature increases. The kinetic energy increases because the molecules move faster as the temperature increases and therefore making more collisions. Therefore, the pressure increases. This results in the egg being pushed slightly above the mouth of the flask.
However, there is not enough pressure to send it into the air. However, there is enough pressure to allow some of the hot air to escape, and once the paper burns out, which will then result in a low air pressure inside the flask, the air pressure decreases because of the decreasing temperature and decreases the amount of collisions. And since the volume is constant, the pressure inside the flask is now lower than the pressure outside the flask. The net pressure outside the flask is so great that it, along with the force of gravity, will push the egg into the flask.
And how it applies, let's use Gay-Lussac's gas law formula and apply it to a real-life situation. Once again, this formula is used when the volume is constant. The formula for Gay-Lussac's law is the initial pressure divided by the initial temperature, which is equal to the final pressure divided by the final temperature.
Use P1 divided by T1 equals P2 divided by 2 N because it means the same thing. The first thing we need to do is ensure that the pressure units are the same, temperature is in Kelvin, and that the volume units must also be the same. Then we must identify the value that we are trying to solve for.
For our practiced equation, we will be starting with our initial pressure and temperature at STP, which stands for standard temperature and pressure, and we will be finding the final pressure while at a temperature of 99 Kelvin.
Standard temperature and pressure, STP, is when the temperature is at 0 degrees Celsius, 273 Kelvin, and where the pressure is 101.3 atmospheres, or 760 millimeters of mercury, or 760 torrs.
So let's assume that a tank of hydrogen gas has a constant volume of 2 liters at STP, and then the temperature changes to 99 Kelvin. What is the pressure after the temperature has changed?
So what is the final pressure? 101.3 atmospheres divided by 273 Kelvin equals final pressure divided by 99 Kelvin. Cross multiply and you'll get 101.3 times 99 divided by 273 to find the final pressure. The final pressure is equal to 10,028.7 divided by 273 Kelvin. The final pressure is equal to 36.73 atmosphere.
So now you've obtained a much greater understanding of the gas laws, and in particular Gay-Lussac's law.
We would like to thank you for tuning in and watching our demonstration for our grade 11 chemistry summative
Tune in next week for another episode
of Chemistry for Dummies.
Bye!
Now, why did it just extinguish?
Wear closed-toed shoes. You've got to be kidding me.
This isn't working.
Is it because it's broken?
No, it can't. No, that's not it. Don't get my stubby thumb in the video. I don't want people to see it. Yeah, we do. Forgot to roll it up.
Hi, Danny. Picking up eggs now. Are you guys
Okay, we can do this. 1, 2, 3, go. Oh, are you gonna cut this part out?
Probably.
So we'd like to thank you so much for watching this video. That was awesome.
Yes.
That was not awesome. Okay, where does it go? Oh, there. Okay, forget that.